Objectives. At the end of the course, the user will be able to understand the basic terms used in development of database, get knowledge on each sections of database design cycle, know about prototyping, know to design a database application. Introduction. A relational database management system, that is RDBMS, is a database management system DBMS that is based on the relational model as introduced by E.F. Codd. Terms. An RDBMS includes various terms as follows: table, field, record or row, column or attribute, column name, table, field, record or row, column or attribute. Column name, table name, relational model represents data in the form of table. Employee table. The table is a collection of related data entries and it consists of columns and rows. A table is the most common and simplest form of data storage in a relational database. Field. Employee table. A table is broken up into smaller entities called fields. The fields in the employee table consist of ID, name, age, address, and salary. Employee table. A field is a column in a table that is designed to maintain specific information about every record in the table. Record or row. A record, also called a row of data, is each individual entry that exists in a table. A record is a horizontal entity in a table. For example, there are 7 records in the above employees table. Following is a single row of data or record in the employees table. Column or attribute. A column is a vertical entity in a table that contains all information associated with a specific field in a table. For example, a column in the employees table is address, which represents a location description and would consist of the following: column name. Each column in the table is given a name. This name is used to refer value in the column. Table name. Each table is given a name. This is used to refer the name. The name depicts the content of the table. Null value. SQL constraints. Constraints are the rules enforced on data columns on the table. These are used to limit the type of data that can go into a table. This ensures ensures the accuracy and reliability of the data in the database. Constraints can be specified when a table is created, that is with the create table statement, or after the table is created, that is with the alter table statement. Constraints could be column level or table level as follows. Column level constraints are applied only to one column. Table level constraints are applied to the whole table. The following are commonly used constraints available in SQL. Not null constraint enforces a column to not accept null value. Default constraint. It is used to insert a default value into a column when none is specified. Primary key. Uniquely identified each row or record in a database table. Foreign key. A foreign key is a field in a table that matches the primary key column of another table. Check constraint. The check constraint is used to limit the value range that can be placed in a column. Data integrity. The following categories of data integrity exist with each IDBMS. Entity integrity, domain integrity, referential integrity, user-defined integrity. Database normalization. Database normalization is the process of efficiently organizing data in a database. There are two reasons of the normalization process. Minimizing redundant data minimizing the insert, delete, and update deviations. Database design. The database design is a process of designing the logical and physical structure of one or more databases. The reason behind it is to define set of applications and support the overall operations and objectives of an enterprise to the user's need. There are many approaches to the design of a database as given below: bottom-up approach, top-down approach, inside-out approach, mixed strategy approach. Bottom-up database approach. The bottom-up database design approach starts at the fundamental level of attributes or abstractions, that is, the properties of entities and relationships. It then combines or adds to these abstractions, which are grouped into relations that represent types of entities and relationships between entities. New relationship among entity types may be added as the design progresses. The bottom-up approach is appropriate for the design of simple databases with a relatively small number of attributes. The normalization process also represents a bottom-up approach to database design. The process of generalizing entity types into higher-level generalized superclasses is another example of bottom-up approach. Top-down database design approach. The top-down database design approach starts with the development of data models or schemas. It contains high-level abstractions, that is, entities and relationships. The successive top-down refinements are applied to identify lower-level entities, relationships, and its associated attributes. The ER model is an example of top-down approach and is more suitable for the design of complex databases. Inside-out database design approach. The inside-out database design approach starts with the identification of set of major entities and then spreading out to other entities, relationships, and attributes associated with those which are identified first. The inside-out database design approach uses both the bottom-up and top-down approach instead of following any particular approach. Mixed strategy database design approach. The mixed strategy database design approach uses both the bottom-up and top-down approach. Instead of following any particular approach for various parts of the data model before finally combining all parts together. In this case, the requirements are partitioned according to a top-down approach, and part of the schema is designed for each partition according to bottom-up approach. Finally, all the schema parts are combined together. Database design, data requirements collection and analysis, conceptual database design, DBMS selection, logical database design, physical database design, prototyping, database implementation and tuning, database design phase diagram. Database requirement analysis. Requirement analysis is the process of a detailed analysis of the expectations of the users. It is time-consuming, but it is an important phase of database design. It includes the following activities: collection and analysis of current data processing, study of current operating environment and planned use of information, responses to user questionnaires are analyzed, analysis of general business functions and their database needs, justify need for new databases in support of business. Conceptual database design. Conceptual database design defined as the following process: analyzing overall data requirements of the proposed information system of an organization, defining the data elements for inclusion in the database, the relationships between them, and the value constraints. The value constraint is a rule defining the permissible values for a specific data item. Constructing a model of the information used in an enterprise is independent of all physical considerations. As shown in the given figure, the conceptual database design stage involves two parallel activities, namely, conceptual schema design is to examine the data requirements and produce a conceptual database schema. Transaction and application design is to examine the database application and produce high-level specifications. The conceptual database design step includes the following: development of primary conceptual data model, including data models and relationships. Developing a detailed conceptual data model, including all entities, relationships, attributes, and business rules. Making conceptual data models consistent with other models of information system. Specify the functional characteristics of database transaction. DBMS selection. The purpose of selecting particular DBMS is to meet the current and expanding future requirements of the enterprise. The selection of an appropriate DBMS to support the database application is governed by the following two main factors: technical factors, economic factors. Technical factor. The technical factors are concerned with the suitability of the DBMS for the intended task to be performed. It considers issues such as types of DBMS such as relational, hierarchical, networking, object-oriented, object-relational, and so on. Storage structure, access path that the DBMS supports, user and programmer interfaces available, types of high-level query languages, availability of development tools, ability to interface with other DBMS via standard interfaces, an architectural option related to client-server operation. Economic factor. The economic factors are concerned with the cost of DBMS product and consider the following issues: cost of additional hardware and software required to support the DBMS system, purchase cost of basic DBMS software and other products such as language options, different interface options, recovery and backup options, special access methods, documentation, and so on. Cost associated with the changeover, cost of staff training, maintenance, and database creation and conversion. Logical database design. The logical database design defined as follows: creating a conceptual schema and external schemas from the high-level data model of conceptual database design. organizing the data fields into non-redundant groupings based on the data relationship and an initial arrangement of those logical groupings into structures. Constructing a model of the information used in an enterprise based on a specific data model but independent of a particular DBMS and other physical considerations. There are several techniques for performing logical database design, each with its own emphasis and approach. The logical database design step includes the following: detailed analysis of transactions, forms, displays, and database views, that is, inquiries. Integrating database views into conceptual data model. Identifying data integrity and security requirements. Physical database design. The physical database design is defined as follows: deriving the physical structure of the database and refitting the derived structures. Selecting the data storage and data access characteristics of the database. On secondary storage, it produces a description of the implementation of the database. Describing the base relations, file organizations, and indexes are used to achieve efficient access to the data and any associated integrity constraints and security measures. The physical database design step includes the following: defining database to DBMS, deciding on physical organization of data, designing database processing programs. Prototyping. Prototyping is a rapid method of interactively building a working model of the proposed database application. It is one of the rapid application development, that is RAD methods, to design a database system. RAD is an interactive process of rapidly repeating analysis, design, and implementation steps until it fulfills the user requirements. Therefore, prototyping is an interactive process of database systems development in which the user requirements are converted to a working system, that is, work between database designer and the user. Prototyping steps. Database implementation and tuning. In implementation and tuning phase, the application programs for processing of databases are written, tested, and installed. The programs for generating reports and displays can be written in standard programming languages like COBOL, C++, Visual Basic, or Visual C++, or in special database processing languages like SQL or non-procedural languages. During this phase, database and application programs are implemented, tested, tuned, and then deployed for service. The database implementation and tuning stage includes the following: coding and testing of database programs, documentation of complete database and users training material, installation of database, conversion of data from earlier systems, errors fixing in database and database applications. Database design and development of an internet bookshop. A bookshop keeps all the books on various subjects, and name of this bookshop is Mr. V and V. It takes order from its customer on a phone or inquiry about order shipments, that is delivery, delivery status, and so on, are handled manually. This enterprise wants to go online and automate its activities by database design and implementation. Mr. V and V Enterprise wants its entire activities on a new website such that customer can access and order for books directly from the internet. Requirement definition and analysis. The following requirements have been identified after the detailed analysis. Mr. V and V's Internet Bookshop has mostly corporate employees who call the bookstore and give ISBN number of a book and quantity. Mr. V and V then prepares a delivery report that contains books they ordered. If enough copies are not available in the stock, additional copies are ordered by Mr. V and V. The delivery is delayed until the new copies arrive and entire order together is shipped. The bookstore's catalog includes all the books that Mr. V and V Enterprise sells. For each book, the catalog contains the following details: ISBN, ISBN number, title of the book, author of the book, per price, book purchase price, sale price, book sales price, pub year of publication of book. Most of the employees of Mr. V and V Enterprise are regulars and their records are kept as follows: name, customer's name, address, customer's address, card number, customer's credit card number, account number, customer's bank account number. On Mr. V and V's website, customers need to identify themselves by the unique customer identification number, that is CUST ID, and then they are allowed to browse the catalog and place orders through online. Conceptual design, entity relation delivery, ER diagram, illustrates a typical ER diagram for Mr. V and V Enterprise Internet Shop. The following tables are created by mapping ER diagram as shown in figure to the relational model. After inserting values, the table will be After inserting values, the table will be After inserting values, the table will be Modified Entity Relation Delivery ER Diagram. The given figure shows modified ER diagram for Mr. V and V Enterprise Internet Shop reflecting modified table definition. To make orders table to satisfy BCNF, we need to decompose that table into two relations: orders, order number, CUST ID, order date; order list of order number, ISBN, quantity, delivery date. The structure of two decomposed table is given as orders table, order list. Database design for an annual rate contract system. Introduction. Microsoft Global Computing System manufacturer computing devices under its brand name. It requires different types of items from various suppliers to manufacture its branded product. Now, the company wants to finalize an annual rate contract with its suppliers for supply of various items. It is required to carry out database for Microsoft Global Computing System to computerize the annual rate contract, that is ARC handling system. Requirement definition and analysis. After a detailed analysis of Microsoft Global Computing System, the following requirements have been identified. The manufacturing company negotiates contract with several suppliers for the supply of different amounts, various items, components at a price that is fixed for 1 year. Orders are placed by the company
it against any of the negotiated contracts for the supply of items at a price, and it is finalized in the contract. An order can consist of any amount of those items that are in the contract. All the items in an order must be supplied as a part of the same contract. However, the sum of any given item type in all orders can be made against one contract cannot exceed the amount of that item type mentioned in the contract. An inquiry would be made to find if a sufficient quantity of an item is available before an order for that item is placed. All the items in an order must be supplied as a part of the same contract. Each order is placed only against one contract and its release is made on behalf of one project. An order is released for one or more item types in that contract. Conceptual design, entity relationship ER diagram. ER diagram for Microsoft Global Computing System depicting high-level description of the data items. Logical database design, table definition and table contents. The following tables are created by mapping ER diagram to the relational model. After inserting values for each of the relations are contracts table, negotiate table, to supply table, items table, orders table, projects table. Change, that is addition, in requirement definition. As it can be observed, the orders table contains field order date and the primary key as ISBN and customer ID. Due to this, a customer cannot order the same book on different days. Let us assume that the following additional requirements are also added. Customer should be able to purchase several different books in a single order. For example, if a customer wants to purchase 5 copies of database systems and 3 copies of software engineering, the customer should be able to place a single order for both the books. Mr. V and V Enterprise will deliver an ordered book as soon as they have enough copies of those books in a single order. They will deliver after some time if ordered books are not in the stock. Employees can place more than one order per day and they can identify the orders they placed. Modified table definition. To accommodate the additional requirements as stated, a new column, that is field order number, will be introduced into the orders table to uniquely identify an order. To purchase several books, both order number and ISBN will be required as the primary key to determine the quantity and delivery date in order table. The modified orders table is orders table. If several orders are placed by the same customer on a single day, these orders will have different order numbers and thus be distinguished. Following can be observed from the modified table definitions. The books table has only one primary key as ISDN and no other functional dependencies hold over the table. Thus, the books table is in BCNF, Boyce Code normal form. The customers table has primary key as cust ID, and since a credit card number uniquely identifies its cardholder, the functional dependency FD card number to cust ID also holds. Since cust ID is a primary key, card number is also a key. No other dependencies hold, so the relation customers is also BCNF. Order number to cust ID, order number to order date. For the orders table, the pair order number and ISBN is the key for the orders table. In addition, since each order is placed by one customer, one specific date, the following two functional dependencies holds.
Summary. In this class, users have learnt about database applications using standard RDBMS, database designing and development of database applications.